So for amines, what you're looking for is just a nitrogen. As soon as you've seen a nitrogen, you need to know a nitrogen can have a maximum of 4 bonds around it. So if you only see 2 bonds, that means the third bond had to be a hydrogen. Or if you only see 1 bond, that means the other 2 bonds have to be a hydrogen. So just be aware of that. And the ending for an amine is amine, so that's nice and simple. 1, 2, which is bute, and I'll end it with bute amine. Butanamine, and then our side chain is a methyl, 1 carbon atom. But the numbering for this is a bit different. Instead of numbering it as a substituent off of the backbone, the number is actually N to signify that it's coming off of the nitrogen atom. So the full name, N-methyl butanamide. Sorry, that's a prop because this is our longest carbon substituent chain off of the nitrogen atom. And it's a 1, 2, 3 carbon chain. This is different. I just have to number the amine, which would be this now functional group, off of carbon number 2 on that prop. So the backbone is actually prop AN because it's a single bonded 3 carbon chain. I signify it's off of carbon number 2, and I have an amine, something happening with a nitrogen atom. That's the backbone for this one. Off of that nitrogen atom, I start numbering the side groups. So it would be a N-methyl, but I'll start numerically. So start with this 1, 2, so that's a N-ethyl, and then a 1 carbon methyl, so N-methyl, propane to amine. And that's the second example. The full name would be all one line, but I just ran out of space, so no spaces there. The third example is the example of a primary amine. So I actually gave you example 1 of all 3. This is a secondary amine, a tertiary amine, and a primary amine. Because I have 2 hydrogen atoms and 1 carbon, so 1 is a primary. I have 3 carbons stuck to this one, so that's a tertiary, and then I have 2 carbons bonded to this one, and a hydrogen must be here to make that one a secondary. So to name primary, it's the same situation. Find your longest carbon chain. 1, 2, 3, 4. It's nice and easy because I only have 1 carbon chain there, and that's bute. And off of the second carbon, I have an amine. And I don't have to put any and this because whenever it's just bonded to hydrogen, you don't have to include it in the name. It's just assumed. Even when you're drawing the structure, like this example here, I didn't even draw the hydrogen because you didn't have to include it. It's just assumed. So then finally we have like the beast example. So find your longest chain and number it so that the amine gets the shortest number, smallest number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a deck. And on my decane, I have a 4 amine. Something's happening with the nitrogen. Then before my carbon backbone name, I want to talk about all of the substituents on that backbone, and I want to start the name with all of the substituents off of the nitrogen. So I like to do that first to get it out of the way. 1, 2, 3 is a N-propyl. And then I can talk about now the backbone substituents, the side chains. So I have off of carbon 7, a 7-fluoro, and off of carbon 3, a 3-hydroxy. 7-fluoro comes first because of the F, and then the 3-hydroxy. If you did it the other way around, I'm sure it would be fine. And then finally we have amides. So just like ethers go to esters, amines go to amides with the addition of a carbonyl functional group. So what you want to do for this one in naming is a lot similar to esters in that the backbone is already decided for you, with carbon 1 being the carbon that has the double bond oxygen carbonyl, and you want to number left, not jump over the nitrogen as 2, 3, 4. So that's my backbone, a 4-carbon bute, single bonds all on that backbone, so AN and then amide. And then I number the side chain as this N1,2-ethyl. The second example here is the backbone that's a benzene. So I've shown it with the 3 double bonds rather than the circle. So it's benz amide. And I have a 1-carbon methyl and a 2-carbon, sorry, I should number that the other way, a 2-carbon ethyl. So alphabetically it should be N-ethyl, N-methyl, benzanamide for the second example. The third example is a 1, 2, 3, 4, 5, so a pentanamide. And I have a 1,2-ethyl and a 1,2-ethyl. So I have 2 ethyls here. So this is where I put a di. So I'm going to write N, N to show 2 places for the 2 ethyls and label that a diethyl. So the full name there is N,N-diethyl pentanamide. And finally, the last example is an alkene in my backbone. So this is your example of a trans isomer. I have an alkene, so I have to decide, is it in a trans conformation or a cis conformation? And because my fluorines are on opposite sides of the double bond, it's trans. And on the backbone, I have a difluoro. So let's number 1, 2, 3, 4, 5, 6, 7, 8. So on carbon number 8, off of carbon number 4, oct for 8, I have a 4-ene because there's a double bond and an amide functional group in this molecule. I just have to put the 4 because that's the carbon where my double bond is on. In front of that, I want to put the difluoro. To start, fluoro is off of carbon number 4, 5, and they're in the trans arrangement. So the full backbone name is trans-4,5-difluorooct-4-enanamide, and that should all be in one line, no spaces. Then I just have to go in and label the side chains off of nitrogen. I have a 1-carbon methyl and a 1, 2, 3-carbon propyl. So alphabetically, that should be N-methyl, N-propyl, no space, trans, 4,5-difluoro-oct-4-enanamide. And that's the craziest it can get.